Welcome back to Robominions.in AI interview preparation app. The topic of this video is deleting a node from a binary search tree. Before tracing the code for deleting the node, I would request you to watch this video on a laptop because you need a bigger screen to clearly visualize the tracing of the code, and the graphical interface is clearly visible on a laptop. Or at least watch it on a phone with a full screen size. If not, if on full screen size, if it's not visible, then I strongly suggest you to watch it on a laptop. Also, download the app Robominions.in AI interview preparation app. After watching this video, you have understood the concept. For revision purpose, you can just control the code using back and next button in the app and also access the code. The app is available in the website robominions.in. You just need to click download latest version, and if your laptop is Windows OS, because this is a desktop app, it runs on the laptop or desktop, so you have to download it for Windows, Linux or Mac OS. So if you have a Windows laptop, click for download for Windows. Yeah. Now let's start tracing the code. So I repeat this in every video for you to remember that you have to trace the code using the arrow mark here. So this will be going to the line of execution of the code. Wherever the code is getting executed, it goes to that line. Okay. So now we have hash include stdi.h, then hash include stdlib.h, then we have create binary search tree.h. So this create binary search tree header file, in this we have insert to BST. So this function is used to insert the values to the binary search tree. The explanation of this part of the code is present in DSA53 video, creating binary search tree. I repeat, DSA53. So please go to that video and watch if you haven't yet watched this part of the code. So let's come back to the main part. Then we have int main. In int main, we are calling insert to BST from the header file create binary search tree.h. So we will insert to the BST and the binary search tree will get created here. So 9 is inserted, 9 less than 11. So 9 is inserted towards the left side. 22 is greater than 11. 22 is inserted on the right side. 18 is less than 22. So sorry, 18 is greater than 11. So comes here. 18 is less than 22. So gets inserted here. Now 40 is greater than 11, greater than 22. So it's inserted to the right side of the 22. Then 8. So we have insert 8. 8 is less than 11, less than 9. So it is inserted to the left of the 9. Now we call delete in BST root comma 11. So we send the root pointer and we want to delete with the node with the value 11. So you want the node 11 to be node with the data value 11 to be deleted. So when I call the delete function, so here the pointer has received root comma key is 11. Okay. So that is this marking is for reference. So then we have temp underscore ptr equal to null. So ptr equal to null is false. The root is not. Right now root is pointing to a valid node, so it is not equal to null. So it is not going to return null. So comes to the next if condition. ptr root of left child equal to null or root of right child equal to null. Right now the ptr is pointing to the root, right? So ptr left child is hash 200 not equal to null. Right child hash 300 is not equal to null. So this if condition is false. Comes to the next if condition, data key. So it checks with the key and the present pointer data. So the key is 11 and the root data or ptr data is also 11. So you can see that is 11. 11 less than 11 is false. Comes to the else if part. 11 greater than 11 is also false. Comes to the else part. Okay. Now it calculates the height of the BST. So you you calculate the height by sending left child and right child. So the left child height is 2, right child height is also 2. To find the height of a tree, we already have explained this part of the code, that is height of a BST or a height of a binary tree. Those are the same code. It has already been explained in the video. DSA 51 finding height of a tree. Please watch the video DSA 51 finding height of tree if you want explanation of this part of the code. In this video, we won't be the program won't be hitting this part of the code. It is going to directly return the height value. But if you want the explanation how this is working, then you have to watch the video DSA 51 finding height of tree. Okay, so now let's continue. So right now, height of left child and height of right child both are same. So it's a 2 greater than 2 is false. It comes to the else part. Then we have in order. Then we have temp underscore PTR equal to in order successor. So we have to find the in order successor from by sending the right child. So when we send PTR of right child is 22. It goes, yeah, it calls the in order successor function. It is sending PTR of right child is 22 node. So it goes to in order successor. Here PTR, this is the PTR is right now for when it receives the pointer, right, it is pointing to this node, that is hash 300. So this node PTR is not null, and PTR of left child, so PTR of left is this one, hash 600, is also not equal to null. So the while condition passes, it goes inside the while condition, PTR equal to PTR of left child. So PTR of left child, so this is the box. So it has this one, now PTR is pointing to this node, and this is a valid node. So it again goes to the while condition. Now PTR is not equal to null, but PTR left child is null. So this while condition fails, comes out of the while and returns the node address hash 600. So it has found the in order successor with a while loop, and then it returns the node address to temp underscore PTR. So now temp underscore PTR is pointing to this node. Now in this function, the PTR here was pointing to the root. I hope you remember this PTR is root. So we are I hope you get you are still in the context, because when the function scope ends, there it has returned, that's the end of that PTR. Okay, now this PTR is root. I hope you're fine. Okay, and now PTR data is equal to temp underscore PTR data. So temp PTR underscore PTR data is 18. 18 is replaced here in the root. Okay, because R11 PTR data is replaced by 18, because that is the data we wanted to delete. Then PTR right child equal to we call the recursive function delete in BST. So we call the recursive function for the right child. So delete in BST PTR of right child, and we send the temp underscore PTR data. So now the data here has so we have found the in order successor. So successor has to replace the deleted value. So 18 has replaced the 11. So 11 has been deleted. Now this node has to be deleted. So to find out to get the node, we recursively call the delete in BST function. Now we have sent PTR of right. PTR of right is hash 300. And temp underscore PTR of data is 18. So when I click next, you see, so yeah, it has marked this one as red. And when I click next again, you can see now delete has been called recursively here. Now the PTR is root of right child, because both the previous PTR was pointing to root. We sent PTR right child, right? That is root of right child. So that has been sent, comma 18 data, that is temp underscore PTR data is 18 has been sent. So I hope you are tracing along with me. Now next, temp underscore ptr equal to null. So new pointer is created. Ptr equal to null is false. Root child is or this node is not null, so it is false. Then we come ptr left child. So for this node, left child is not null, right child is not null, so this becomes false. It comes here, and then now key here is 18 and data of this node is 22. 18 less than 22 is true, so it goes inside the if condition. Now ptr of left child equal to, so for this node left child we call the delete in bst again. So we want to delete this node, so we call the delete in bst ptr left child comma key. So we are calling this bst again. So when I delete in bst again, so when I recursively now I click next, you can see the red mark has gone to this node because we are accessing ptr left child. So left of this node is 18 value, this node, and key here is, the key we have sent is 18, right? The key here is 18 because that is the key we have sent. So when we call the recursive function again, you can see we have delete in bst has been called. Now the ptr is actually root right left child. This is just for our convention. I'm showing you the program gets the address directly. So that is ptr right child was hash 600. So pointer would have directly got hash 600 address, but for understanding purpose, it is actually root right left, right? That is what it is, root right left, and the key is 18. Now we have another new temp underscore ptr equal to null. Then if ptr equal to null, now right now the ptr is not equal to null, but ptr left child. Now for this node we have left child null and right child null. So ptr left child equal to null, ptr right child equal to null. It is true. It goes if ptr equal to root. So is this node root? No, it is not. Then it comes, doesn't go inside the if, it comes to the free of ptr. So this node has been released, so it has been deleted, free, and then it returns null. So now it returns null. So null is returned to which part? So where the delete in bst was called. So it's a recursive function, so it returns to the where the recursive call was made. When I click next, you see the function context has been restored and it was called here, right? ptr left child equal to delete in bst ptr left child comma key was sent here. So this function has returned null. I hope you remember, it has returned null. When I click next, so it is null equal to null. When I click next again, so you see here again this has been replaced. So the node left child, ptr of left child, because here ptr is this node, so its left child is null, has been deleted, so it has been replaced with null. So the if condition is done. Now it goes to, so after that it goes to return ptr. So this ptr address is hash 300. So it was called, so this function has been called from here, if you remember. When I click next, you can see the context of this function has been saved because it was a recursive call, and here the return ptr will return the address of this node again. So when I click next, you see hash 300 is again copied back to the right child. So even though it was previously hash 300, now again it is pointing to the same node. Okay, and then when that is done, then it comes and returns the ptr to the main function. You see, it has returned, even though the ptr is not received, we could have received it to a root because it would have sent the root address, but yeah, but we have not received it. We just wanted to have we just wanted to delete the node with 11. So 18 here node data was replaced replace the 11 and this node was deleted. Then we return from the main function. The time complexity of this deleting a node from a binary search tree is order of log n, because it has to do a order of log n. So it is similar to searching and then like in order successor is searched, and similar in order there is a in order predecessor which goes to the right side of the child. The in order successor goes to the left child. Okay, so yeah, and for revision purpose, if you want to revise this code, you can just click back and next button in the Robominions AI interview preparation app. Don't forget to download this app. This code is available in the app in the code button. When you click the code button, you get access to the code. And if you want to make revisions, you can just click on video tutorials and revise the concept. And just before going to an interview or going for a gate exam or any other competitive exams or competitive programming competitions, or going for a semester end exams, you want to revise all these concepts, right? So you have a opportunity in this application to revise all the computer science algorithmic concepts, and it gives power to your hand. Like you can control the code at whichever stage you want. By just clicking back next, you can control the code. So if you don't understand at specific line where the code is working in certain way, you can just click back and then it goes to that previous execution step, and you can again revise and then again move forward. I hope you like this video. See you guys in the next video. Thank you. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.